Hola, Dr. Taylor here. Dr. Taylor's Pedagogical Notes, and we are looking at fractions, subtracting fractions or subtracting rational numbers. Okay, so let's get right into it. All right, so we're going to look at it from concrete to abstract, just like we always do. There's again the links for everybody. And let's get right into it. 2/3 minus 1/5 is what we're looking at. It's up there in the corner. So I'm going to do the geoboard again. I'm going to blast through it a little bit because if you didn't watch the previous tape or video, probably a good idea to do them in order. But if not, I'm basically going to think of this as a big square pizza that I could cut up into pieces. I'm going to use the rubber band to do it. This is a geoboard presentation. I'm going to use the green for the perimeter. I'm going to use the red for the vertical and the blue for the horizontal partitions. You don't have to have colors. It just makes things easier sometimes. Each student will get one geoboard. They'll work in pairs and they'll compare their fractions and how they combine, or in this case, how many is. I really should have said how many more is. How many more is 2/3 than 1/5, right? Is it going to be a whole lot more or just a little bit more than one or less than one, some fractional part? Let's discover that together. All right, so since we cannot arbitrarily cut things up into any old way, we will need to make our rectangles the dimension of the denominator 3 by 5, okay? Why that does that, I don't know. So I'm going to do this first with the green, and then I'm going to use blue and red to do the numerators. So 3 by 5 is 3 by 5, and again, both people with their geoboard should make that same 3 by 5 rectangular shape. All right, now we're going to cut things up, right? There's the thirds, because it's 2/3, so I've cut this vertically. All right, there's 3 partitions vertically, right? The next geoboard with your partner, you're going to cut it up horizontally with the blue. And there's 5 partitions, because it's fifths, all right? Then, now we're going to look at each other's, and we're going to transfer our thing. Does order matter? Again, something to discover, something to think about. I'm not going to answer that question for you. Or does it? Right? Didn't even see that question at first. But let's take a moment. Does 2 minus 3 equal 3 minus 2? You can use that number line strategy, right, with directionality, and just see if they land in the same spot. So I'd like you to take time. It's got a 1-minute counter. I'd click it in the classroom and you'd go. So go, pause it, and come back. Okay, welcome back. I hope you discovered that there is a subtle difference there, right? All right, so let's take a look at both geoboards and put the blue rubber bands onto the red one, transferring our partitions. And then the red rubber bands transfer onto the blue one, right? And now we have 2 equally cut up pizzas. If this is Emo's, the square beyond compare, right? It's all cut up. So whatever imagery makes it work for you. So what is 3 by 5? I think we're going to know that, okay? And now I want to put in the numerator. The first fraction is 2/3, right? So I'm going to fill in 2 of the 3 pieces, okay? So that's 1/3, and there comes the second third. Now that's 2/3. Of course, with that, I'm going to have to deal with the other side, the second fraction, which is 1/5. So any one of those partitions, I'm going to do 1, 2, 3. So there's 1 of the 5 possible. So that's 1/5. Now remember, subtraction should really say how many more. And I'll adjust that down the road. But how many more is that first number than the second number? But now I can look at it, right? I mean, each pizza is cut into the same size and number of pieces, right? And this represents the number of pieces I ate over here, and this, that one. Well, how many more did this person eat than that one? It's going to become obvious, right? It's a subtraction problem, sure, but what's also used is a comparison problem. If I compare, I can make what is called a 1-to-1 ratio of units until one of the fractions runs out of units in its numerator. So let's do that. We have 2 rectangles. They're 3 by 5, and they're going to be 10 beads here. And how many there? That's right, 3. So now, what we have is 10 minus 3, right? So let's compare. I'm going to take 1 and take 1. So what I'm doing is I'm doing that 1-to-1. I have a 1 minus, because that's a minus sign, a 1 minus 1 is what? Nothing, and I'd swipe them off the table, right? I can't swipe my squares off the table now, so I have to take my 2 beads and take them out of the work. So am I done? Is there still more there? Yes. So I keep taking away. I take 1 out of each one. Am I done? Is there still more in both of them? Yes. So I take another away. And now I'm down to nothing here. That's empty. So how many more was this than that? Well, what's left? That's right. And what's 10 minus 3? Well, let's think about it. Let's count backwards. 10, 9, 8, 7. Right? So counting up or counting down. Counting up to add, counting down to subtract. I'm comparing through cancellation, okay? However you want to look at it. So there is 7 beads left out of a possible how many? What's 3 by 5? There's 7 more out of 15. Okay? I'm rushing through a little bit, but I want to keep the videos as short as possible. You can watch them again, you can pause them, you can go back and rewind. I'll never get tired on video of telling you again and again and again. That's the beauty of it. All right, let's keep going. All right, graphical. Well, I'm going to draw the shapes just like before. I'm going to partition vertically and partition horizontally, okay? And after I've partitioned, I'm going to transfer partitions, or I'm going to color the numerators. It doesn't matter which I do first. On the graphical model, it's easy to do it either way. On the geoboard, it's nice to have all the squares in there before you start stacking stuff on it. So there's 2/3 and 1/5. Notice I chose a different one. Doesn't matter, right? Now I'm going to transfer partitions, right? So the red partitions, that's the thirds. Then I'm going to transfer the fifths this way. All right. Now those are both 3 by 5. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 3, right? So let's count that out. There's 10 out of how many? 15, right? And that's 3 out of how many? 15. So just do a little test. What's 10 out of 15 minus 3 out of 15 going to be? Notice that the bottoms are both 15. That's the common denominator. Again, as I do this, it builds into me a sense of what the common denominator is and how it becomes the number it becomes. Not just a memorized thing, not some butterfly method or whatever that's meaningless without the teacher to remind you of why it works. Okay? This is meaningful, and you can do it yourself again and again and again. So I have 10, and again, I want to know how many more is this than that, or how many more is 10 than 3? I think we can do that again. It's subtraction, right? And we're going to cancel out, cancel out, cancel out. There's nothing left. How many more is it? That's right, it's 7. 7 is left. 7 out of how many? It's not just 7 pieces, is it? It is 7 out of, that's right, 15. Okay? Huh. Oh, look at that. There's a typo. That should say 7. We'll fix that. All right, now abstract. How do I think about this abstractly? Again, I can visualize the partitions, or I can begin to, and this is where the algorithm begins to become useful. Finally, it's like, okay, well, I know it's 3 by 5, and that 3 gets multiplied by 5, and that 5 gets multiplied by 3, and what I do to the bottom, I do to the top. That's where the algorithm becomes meaningful. If I can't remember, I can think about the picture. I can compare and count. I can do the area, or I can just think through the algorithm. Either case, I'm going to get 13 out of 15. All right, that is subtraction of fractions. I hope it helped. Watch it again and again. Go back and look at the slideshow, and I will see you in the next one, multiplication of rational numbers. Thank you.